In this video, I'd like to talk about how to graph the equation of a line where we're given a point on the line and we're given the slope of the line. So first, let's plot this point. We're at an x value of -6 and a y value of 1. So we go over left 6, so -1, 2, 3, 4, 5, 6. So right here for x, and then up 1 for y. So we have that point right there. That's actually going to be on our line. And we have a slope of 5. And remember that slope, which we usually denote with the letter m, is defined as how much the line goes up or down divided by how much it goes left or right. Or essentially, it's the rise divided by the run. In this case, our slope is equal to 5. And whenever your slope is a whole number, I find it helpful to write it as a fraction. So I'm going to write it as 5 over 1, since you can divide anything by 1 and the number would still be the same. And the reason I wrote it as a fraction is because it's easier now to see how much we go up and how much we go over. So it looks like we rise a positive 5 and we run 1 to the right. So we're going to first count over 1, so that's our run, so that's going to bring us to here, and then we want to go up 5 units. Or essentially, we were at a y value of 1, so now we're going to be at a y value of 6. So 1, 2, 3, 4, 5, 6. So it should be something right there. And now that we have 2 points, we can connect them with a line. So you can get at least a rough idea of what the graph of this line should look like. So let's look at a couple more examples now. So now we have the point -5, -3, and a slope of -2. So again, we're going to start first by just graphing this point. So we go to the left 5 and then down 3. So 1, 2, 3, 4, 5, and then down 3, 1, 2, 3. So right there, that green point would be actually on our line. And then our slope is -2. But remember, if it's written as a whole number, we could write it as -2 divided by 1, since that way it's much easier to compare it to our rise over our run. And it looks like we're going to go down 2 and then over 1. So we can count down 2, so 1, 2 down, and then over 1, so we should be right there. And from here, we can just connect these with a line. And notice with this line that since we have a negative slope, it's downward sloping as x increases. Or essentially, negative slopes always look something like that, whereas a positive slope essentially slopes upward as x increases. So it could look something like any of these, where if we had a slope of 0, it would actually be right in the middle of those. A slope of 0 would just be a horizontal line. And knowing that a negative slope would make it downward sloping as x increases, at least gives us a simple way to feel confident that our work is correct. For instance, if we graphed a line and its slope looks something like that, we could know right away that we made a mistake. But since this slope is negative, it is going downward, that matches up at least with the slope we started with. So now moving on to our last problem. We're again given a point and we're given a slope. So first, we again want to graph this point here, this -2, 4. So we go left 2 in the x direction and then up 4 in the y direction. So we have that point right there. And with this slope, it's already written as a fraction, 2 divided by 5. So we can compare that to our rise divided by our run. So it looks like we go up 2 and then to the right 5. So we can count up 2 units there and to the right 5. So we're at -2. So adding 2 to that brings us to 0. So we just need to go 3 more. So 1, 2, 3. So somewhere right there. And we can again just connect these with a line now. So that can at least give us a rough idea of what the graph of this line should be.